Hi, everyone, and welcome back to Tech SEO Mini Boost. I hope you had a wonderful break. And if you're just joining us for the first time today, welcome to the conference. We're so excited to have you tuning in and participating in the event. I'm Megan Lavin from the Catalyst team. I'm joined by Paul Shapiro and Aleda Solis. We're going to be your trusty MCs for today's virtual event. So we'll be providing some perspective and directions along the way. But please also know that there's an event FAQs tab at the top of our site, which includes important information should you run into any platform issues. And it also addresses some commonly asked questions about the event. So know that's there. And then also for anyone just dialing in, we're starting off each session by checking in with a partner. We're getting a brief hello from their team. We're hearing what's new at their organizations, and we're getting some visibility into their products, capabilities, and tools. So before we pass things off to Jamie for her presentation, we're going to hear from our friends at DeepCrawl.
Every day, 3.5 billion searches are typed into Google, and it's never been more important to get your pages and products to the top of the results. Getting there is complicated and competition is intense. Businesses need the right tools to navigate technical SEO, especially when your sites span thousands to millions of pages, multiple languages and countries across the world. That's what DeepCrawl is here for. We help the world's biggest brands increase their rankings, lower their customer acquisition costs, and drive revenue through the one thing our marketing counterparts often overlook: technical SEO. Our SEO analytics hubs help businesses like yours detect opportunities for growth, increase performance, all through our in-depth technical SEO analytics and insights. We can protect your website from releasing harmful code to production through our SEO automation hub by alerting you to technical SEO issues before they become a problem. All of this in one easy-to-use integrated platform. Don't search for SEO success. Grow fearlessly with DeepCrawl.
Thank you, DeepCrawl. So great to hear from you guys. And with that, we're actually going to move into our next presentation. Next up, we have Jamie Indigo presenting Rendering Strategies, Measuring the Devil's Details in Core Web Vitals. And this is actually Jamie's second time presenting at Tech SEO Boost, and we're absolutely thrilled to have her back. Aleda and Paul, what are you guys most looking forward to in Jamie's presentation today?
I mean, the timing of this is impeccable, right? We have this update coming in May. We're talking about Core Web Vitals. Jamie's incredible. Every time she speaks, it's pure gold.
She's the queen of JavaScript, and I am so very looking forward to hear her explain and go through how JavaScript rendering impacts all the metrics of Core Web Vitals. So I'm so very looking forward to that.
Wonderful. So without any further ado, let's welcome Jamie Indigo.
Thank you so much. It's an absolute pleasure to be back here at Tech Boost. My name is Jamie Indigo, and today we're going to be looking at rendering strategies and measuring the devil's details with Web Core Vitals. We know that the page experience ranking signal is coming. It feels imminent. It is like a kaiju about to destroy our website's ranking in the city, or at least that's the perspective some folks may have. It's okay. What we're going to do today is understand our Core Web Vital metrics and how they're measured. We're going to look at where and how Core Web Vitals occur, and then rendering strategies, because each of them has a respective benefit pratfall, and we can learn some mitigation tactics about how to make our Core Web Vital experience performant, not only for the upcoming ranking signal, but for humans. Let's dive in. We probably know these three metrics by now. They are ubiquitous. They are buzzwords across all of the internet. We're going to start off with a little dive into what these metrics are and a little bit of information about how they're recorded. Largest contentful paint represents perceived loading experience. This is a human-centric metric to answer the question of, can my thumb stop hovering? Is the content I've asked for available? Technically speaking, it's measured when a node representing a large contentful paint in the initial viewport is available to a user. For behaviors, multiple pages, if they share a template, will typically have the same largest contentful paint node. This is highly beneficial because When we fix it in one place, we fix it across multiple pages. Ultimately, we want to get our largest contentful paint to under 2.5 seconds. So what can be our largest contentful paint? It can be text, images, or a poster for a video. We can define largest contentful paint in DevTools. If you're working on a set of problematic pages and you're not sure what makes up that node, open from DevTools the Performance panel, tick that box for Web Vitals, and profile the page. When you do this, you'll be able to see a marker of the node that is your largest contentful paint. The more specific you are with your development team and providing information about what needs to be fixed, the more likely you are to get that ticket, prioritize in your backlog, and get changes made. You can see right here the marker and specifically the related node pulled up. Be specific. Give your dev team what they need to complete your tasks. First input delay measures how responsive a page is. If I'm on an e-commerce site and I have that largest contentful paint, I can see that button for buy, and that is my intent. I want to be able to click on that. If I have a very slow first input delay, I'm not able to do that. So this represents responsiveness to a user's input. We want to have this achievable in under 100 milliseconds. And it's very important to note that first input delay is only available as field data. So when we talk about Chrome user experience data, the data is available in Search Console, this will be represented as FID. When we look at the technical details of how FID occurs, it's measuring how occupied the main thread is on the browser. We can see here tasks taking up the bandwidth of that main thread to the point where the user's input is received and processed. If we're doing our lab test to go ahead and debug, figure out how to make our site more performant, we can use total blocking time as our proxy. This also measures responsiveness to user input. It has a slightly different threshold for being considered performant. We want to have this under 300 milliseconds. We can see this data in Chrome DevTools by going into that same performance report and looking for the summary of total blocking time. Total blocking time is defined slightly differently. Any task that takes longer than 50 milliseconds, the time over 50 milliseconds is considered blocking time. If a task takes 70 milliseconds, then 20 milliseconds of that would be total blocking time. Cumulative layout shift is my personal favorite because when you load a site and you go to interact and everything shifts, it's a very frustrating experience. So while this represents visual stability, it also represents user frustration. And it's the unique calculation, not measured in time. It's measured in how much moves and how far it moves, the size of the element and how much it moved. We want to have a calculated score of under 0.1. This behavior often comes from an element that can be reused across pages. Chances are it's your cookie notice. We can identify the CLS element in Chrome DevTools as well. It's under that experience bar. When we click on that, we can see exactly what element has been moved. It's important to note there can be multiple elements causing cumulative layout shift. Now that we know the three challenges we're up against, let's look at the arena. We have a lot of buzz around this concept of how do we make this site performant. And it's really interesting because ultimately the arena for the Core Web Vitals battle fits in our pocket. It's very small. It's a viewport typically about 360 by 640. It's the size of a phone's viewport. Core Web Vitals measure how long it takes to just provide content on a mobile device above the fold. Initial viewport above the fold, we're going to use those words interchangeably here. It's a very simple formula. We have a user, we have a screen, we have a content. How do we get there? Well, this is done through rendering. And rendering is the process of turning HTML into pixels. Google doesn't have eyes. The rendered HTML is the output the search engine bot is looking for. Let's dive into the pixel pipeline, turning HTML into visual elements on a screen. We start off with JavaScript. It's going to make changes to the initial HTML that's been parsed, add in new content. We can see that as added elements, changed elements, and we'll then move to the styling. Style calculations are the process of figuring out which CSS rules apply to which elements based on matching selectors. We have our DOM tree created by JavaScript being added to the initial HTML and attached to the style rules created. So now our paragraph has a font size, has a font weight, has a color. These are important for the visual cues created on the page. Next up is our layout. So once the browser knows which rules apply to an element, it can calculate how much space they take up on a screen. We've created the render tree. The render tree is the result of our CSS style rules attached to our DOM tree and then measured to the viewport that they're delivering in. If you're using responsive design, this is where it figures out, based on the size of that screen, also known as the viewport, where do I place elements, where do they go? Next up, we're going to paint. Paint is the process of filling in pixels. It involves drawing out text, colors, images, borders. It's typically done in multiple layers. So our largest contentful paint is going to occur here. In our layout, we're going to see some layout shifts. Painting is going to create that visual component to the screen. It's not finalized, but it's our largest contentful paint. Our last step when that page is going to be finished is composited. All those layers are dropped down, put together, and made complete. When we have the full render tree done, composited, all the content is available to the user on the screen. Sounds really easy. It was a pretty small arena, just a couple of steps. We tend to think it's going to be just filling in, coloring in the lines. It actually ends up being a little bit more like this. So the end result of how we render is always the same. We're always wanting that composite page, the same content available, but the difference is in how we do this. And that comes in the flavor of our rendering strategies. So let's look at them. Each of them can have benefits, can have significant troubles being performant in this new Core Web Vitals world. We have 5 we're going to go over today. There are always more. It's the internet. There are always more options. So we're going to look at client side, server side, static, dynamic, and rehydration. First up, most popular, client side. Client side rendering means that when your server is asked for a page, it ships back a bit of a shell. In this example, I actually used one with a shadow DOM. If you've got that, you have larger problems. But you are still relying either way on the user's device to go ahead and do all of the heavy lifting and provide the content to them. We have significant issues if we are entirely reliant on client-side rendering. What can cause poor LCP? Client-side rendering. That's it. That's the slide. Each script that we use to generate that content on the front end has a probability of failing. We can see with JavaScript, this product detail page on the screen is full. It's robust. It gives me good information. I have a price I can buy. Without JavaScript, it doesn't answer a user's intent. And even if we have very successful script execution, 1, we're blind to it. 2, there's still a probability of failure. So if we go ahead and ship this out and we have 4 scripts to execute, and each one of these scripts delivers a specific piece of content to that product detail page. If one fails, we lose important information. It could be something like the product name, SKU, and price. These are critical elements that would answer a user's intent, and they're very difficult to diagnose because they have a tendency to happen. If we have the main bundle fail, the one that calls all of the other scripts, we don't have content, and we don't know that it has happened. So to mitigate this, if you're doing client-side rendering, avoid critical chains. Core Web Vitals is another way of looking at what's known as the critical rendering path. It's painting content above the fold. If we have chains in that path, that means we have to call a script that calls a script that calls a script that creates an element. They are dependencies and they are weaknesses. They each take time to execute, and they're going to make your site less performant. When it's important, don't chain it. It gets called directly. Next up, render blocking. Everyone has to wait while JavaScript and CSS do their thing. There are 2 types of resources that block rendering. We can have scripts that are in the head of the document. If they don't have an asynchronous or defer tag, they're going to be problematic. So that third-party tool you have that promised to be magic as long as you just put that script right above the opening head tag, yeah, that's going to be a problem. Because under HTML, HTML5 protocol, Googlebot, and a user's browser, it's going to go ahead and wait for that script to do its thing. It's going to wait for that third party to respond, for that script to execute before it moves along to the next element of the head. And the head, of course, is all of these important things that we need to create our page. We can also have style sheets be render blocking. If it doesn't have a disabled attribute, if it doesn't set a media attribute that matches the device that's requesting it, it's render blocking. We can mitigate this by deferring non-critical assets. That magical third-party tool gets deferred. If it doesn't contribute meaningfully to the page above the fold, it can wait its turn. We can also lazy load images natively. This is a beautiful thing as we begin to paint content on our screen. If it's below the fold, it can wait. We can inline very important things like our above the fold styles. You can use the style inline after critical metadata before you call any scripts, any third-party goodies. Keep those inline styles small. You want to keep them under 1 kilobyte. You want to remove those inline functions from the style sheets that you're calling after that, so you're not duplicating it, not creating more calculations for the browser. Next up, what causes poor LCP for client-side rendering? Performance. We have a ton of scripts running, creating new elements, moving things around. It's important to know Google will interrupt and limit CPU consumption, large scripts, and so will users' devices. If a user is on Chrome and you have maybe a third-party tool that helps you curate categories on your site, and it's all client-side rendered, if you look in the browser, check it out, you might see a notification that says, hey, if a user has a poor connection, we're not even going to try and execute this script. This is important. If all of your content is reliant on a third-party script that's very bulky, it's not even going to run. Poor first input delay, that ability to interact. This is actually true for any site, regardless of what your rendering strategy is. What causes poor first input delay? JavaScript. Without fail, it is JavaScript. And you can see over here in our animation, we are looking at the total blocking time. So any of the tasks that have that red little mark in the corner, I'm going to let you know that they're long tasks, they're bulky tasks. As you begin to work in improving first input delay, look for the big ones, figure out how we can break them down. Ultimately, we want to mitigate those large tasks by breaking out our scripts into small, valuable functions, those that execute first or those above the fold. And we don't want to ship content that is not valuable. We can use the coverage report in Chrome Developer Tools to see how much is actually executed. If we're shipping 3 megs of unused script, these are massive performance opportunities for us, and that'll be seen in Core Web Vitals as an improved FID. When it comes to your cumulative layout shift, we're always going to be looking for dimensions on our images and ads. We may not have those set inherently, just assume the browser would figure out what size that was, but if it's not declared, the browser can't go ahead and block off that space for the image. So once the image loads, everything jumps down. It's pretty easy to fix. Use placeholders for ads. If you've got third-party ads, you're a publishing site, you rely on those, figure out what the largest set of that ad space will be, and reserve a space for that to populate on your page. A lot of sites back in the day did this fun thing where they would bookend. They would load the header and footer and load the content in. And for client-side loading, this is very problematic because if you load something in the initial viewport, it is now part of your CLS calculation. A new player has entered the ring. If you put it in the initial viewport, it is part of the calculation. Consider that as you load. Prioritize what you load. Remember that layout score is the impact fraction times the distance fraction. We mitigate this by loading what matters when it matters. Document.write. That third-party tool that's Magic probably is using this one. Chances are it wasn't your dev's work. So modern browsers work with speculative parsing of the main thread. It means they read ahead. They do next week's homework this week. And when we use document.write, suddenly that homework is in a whole different book. We have to throw away all that work they put into it. So talk to your point of contact for that Magic third-party tool. Using document.write, there are better ways to do this. Style recalculations will affect most sites with some poor CLS. So when we change the DOM and write it and rewrite it and rewrite it, That's an expenditure to the main thread, and it's a visual change for a user. So we can mitigate this by lessening the scope and complexity of style calculations. This is where you team up with your UX. This is where you begin that ally relationship because you are all in this one together. You want to reduce the scope and complexity of your selectors. Reduce the number of elements being styled. Simplicity is more valuable than fancy features in a performance site. So measure how much it takes to recalculate styles. Metrics will help you make good decisions and make good iterations as you move forward. And if you can, work with your UX team to move towards the BEM method. So block element modifier. It's class-centric and it allows you to scale out and have a consistent reusable module library. Web fonts are one of the biggest challenges when it comes to cumulative layout shift. If a font loads late, so you're using a standard Google font, when that finally responds, the whole page will flash. So in order to mitigate this, we need to preload that font. Preload is a signal that tells the browser, fetch this now. This is going to be of use. It's very simple to add, very useful for you in mitigating cumulative layout shift. Now we get to server-side rendering. For a while there, we had kind of thought this was a golden standard. Like, this is what we want. We want to have that Bing-proof, fully parsed HTML. It can be a little bit tricky. So to be clear, I know there's a lot of terminology that comes along with server-side rendering. This specifically is your server making the calculations on the fly when requested to create the content, the fully parsed HTML to send back to the user. And it can cause some poor server response times. We have 4 things that cause poor LCP. This is one of them. This is a scenario where it's time to work with the developers. Find out what calculations are being made and do they contribute valuable content on the page. Fundamentally, I love Web Core Vitals. If for nothing else, they're making SEOs work with devs and UX. You are a team, you are a front-end team, and you are trying to make a website better for users and search engines. And maybe this imminent Doom update is just getting that executive buy-in you need to make progress. Media declarations are another big blocker for achieving solid LCP. So if we don't declare what our media is it X small, is it large, based on our viewport, and we want to always have that be relative to the viewport, then calculations for every size of viewport in your style sheet must be done in order to put that content on the page. This is what makes CSS render blocking. We can mitigate this with dynamic media queries. So we declare a viewport size and then we use a dynamic media query based on that. If I have a small device, then I'm going to call the style sheet for small viewports. Next up, static rendering. Again, to define this one, static rendering is at the time of build. We execute the code, we make HTML versions of the pages that are ready when a user calls for them. Sounds kind of magical, and in a perfect world, maybe it would be. It depends on your site. This is a situation of your mileage may vary. Some pros here. We have a very low time to first byte. We deliver fully parsed HTML. Unfortunately, this is significant computing costs. This is money. You have to have the servers to go ahead and execute all of this. You don't have static rendering to scale, it doesn't work. It's tricky to get right too. The devil's details are down the rabbit hole here. So, and this only will work for static content, which means if you are doing personalization A/B testing, this is not for you. If you're an e-commerce site where your products prices change daily, your availability of products change rapidly, this is not for you. Dynamic rendering. Do you all remember back in 2018, I/O and the webmaster team kind of blew up our idea of how Googlebot understood JavaScript? We've come a long way since then. Unfortunately, one of the things that's stuck around since then is, we should use dynamic rendering. And that's where we kind of have a bouncer who is verifying who the requests are coming from. And if it's a crawler, it gets that pre-rendered, static rendered version or server rendered version passed back to them. Ultimately, the goal is they get the fully parsed HTML. Real users are getting the client-side build instead. This was a very fashionable talking point for SEOs for a minute, and it seemed like a good idea because the webmasters announced it at I/O. It's a big deal. It's also a terrible idea because now we have twice the cost, twice the testing, twice the QA, and we have half the visibility. If we're doing dynamic rendering, are we sure the content matches Do you have a means to test that? Do you have a means to test that at scale? This one, as Martin put it in a recent Google event, is not reasonable. If you have not yet adopted dynamic rendering, this is not the time to jump into that. All right, our last rendering strategy is called rehydration. It can also be known as progressive hydration, as isomorphic rendering. It's got a bunch of fancy names. But what it means is we have a request to our server. Our server returns back fully parsed HTML for above the fold content, or for our hero content, for content that matches the user's intent, whether it be transactional, informational, or location-based. And the supplementary content are, you might also like our related blogs, our footer. No one cares about your footer if they can't see that above the fold, what they came there for. That's all loaded in the user's browser. And this can be easily discovered by Google. It takes a little bit of nuance to it, but ultimately, it loads what matters when it matters. It gets that above fold content to a user in a meaningful way that allows them to interact. Core Web Vitals isn't coming because our great secret overlords really want to press us for something new and exciting. It's coming because users have a very short attention span. You have 4 to 8 seconds to get a user to go ahead and complete the task that they're on your page to do before you lose their attention and they leave. And if your site passes Web Core Vitals assessments, well, users are 24% less likely to abandon that page load. Less abandonment, more chance for conversion. And that's not just with organic traffic. That's across every device, every medium, all of your users. The page experience update and the introduction of Core Web Vitals into ranking signals isn't the apocalypse, but it is a good chance to prioritize real human users, to make sure that people coming to your site get what they need and that you have that stakeholder buy-in to do this in a meaningful way. Maybe this is the first chance you've had to get development resources behind your initiative. Use this, leverage it. Thank you so much for joining me today. My name is Jamie Indigo. I'm part of the Deep Crowd team. I cannot wait to see you all back in real life, in person, for the next Tech SEO boost. And I appreciate you spending your time with me today. Thank you.
Thanks, Jamie. That was incredible. Thank you so much.
It was so impressive. I love that. And this is the type of granularity that we need to go and talk with web developers in order to optimize as much as possible for Core Web Vitals, right? So yeah, mind blown. I love it. All the pros and cons, the different approaches. Thank you very much, Jamie. And I am also very excited for our next presentation with Brian Ta.